Hello everyone and welcome back to Turning Turing. Today we'll be discussing a hard problem from Leetcode. This is Leetcode problem 2402, meeting rooms 3. Let's quickly go through the problem statement once. So it says you're given an integer n and there are n rooms numbered from 0 to n minus 1. You are given a 2D integer array meetings where meetings of I is equal to start, end. Means that a meeting will be held during the half closed time interval, start time included, end time excluded, and all the start time values are unique. Meetings are allocated to rooms in the following manner. Each meeting will take place in the unused room with the lowest number. If there are no available rooms, the meeting will be delayed until a room becomes free. The delayed meeting should have the same duration as the original meeting. When a room becomes unused, meeting that have an earlier original start time should be given the room. So return the number of the room that held the most meetings. And if there are multiple rooms, return the room with the lowest number. So a few things to note here. First thing is that when you have scheduling questions with start and end times, you usually sort it based on the start time and then proceed with further processing. Sorting by start time gives you the order in which the events will actually happen and you can logically handle the business logic. This is just an observation and might not work in some rare cases. Second thing is that you can see the order of meeting room is small, less than equal to 100, and meetings are of the order of 10 raised to power 5. This is probably designed in such a way so that you can pick each meeting one by one and then probably iterate over all the rooms and select the best one. Even if you check each room once for every meeting, you'll be iterating over each room 10 raised to power 5 times. So total time complexity will be of the order of 10 raised to power 7 in the worst case, which can be computed within the given runtime limit. But just a heads up, these are just observations that might help you while problem solving, but you should not rely on such observations or hacks. You should always focus on the concept while learning and practicing. Now, based on these observations, it becomes very easy to solve this particular question now. We can sort the meeting by their start time. Now, if we pick the meetings in ascending order of start time, we will be picking the meeting in the order in which they will actually take place. Now, for each meeting, we can iterate over all the rooms and pick the best one. The criteria for selecting the best one is the one which will be available first, and if more than one are available at the same time, then the least number one will be the best one. And what we can do is when we select a room, we can store the next availability of the room and also keep a track of the count of the meetings in this room. And when we iterate over the rooms for the next meeting, we use the updated available timings of the room to make a decision. So let's try the example given in the problem statement itself, which is n equal to 2, and we've been given the meetings array. Now these meetings have already been sorted by their start time. So we have rooms 0 and 1. Now we pick the first meeting 0, 10. 0 is empty, so we'll already pick 0 and we'll update the next availability to 10 because it'll be available at 10. Then we get the next meeting 1, 5. 1, 5 will not be allocated in 0 because this room will be available at 10 and we have a meeting at 1. So we'll put it in the next lowest available room, which is 1. So we'll put it in room 1 and we'll update the availability of room 1 to 5. Now we have another meeting 2, 7. Now 2, 7 will not be allocated in 0 because room will be available at 10 and it will not be allocated in room 1 as well, which will be available at 5. So for meeting 3, we'll probably have to wait till 5 because at 5 room 1 will become available and that is the lowest available room. So we'll assign the meeting 3 to room 1. Now third meeting has a duration of 5, 7 minus 2. So if the meeting starts at 5, the room will be next available at 5 plus 5, which is 10. So the next availability is 10. Now we have a meeting starting at 3. So both the rooms will be available at 10. Now when two rooms are available, we pick the lowest one. So we'll be assigning this meeting to room 0 and this meeting has a duration of 1, 4 minus 3. and 0th room will be available at 10. So the next availability will be at 10 plus 1, which is 11. Now we have allocated all the meetings. So room 0 had 2 meetings, room 1 had 2 meetings. Now we had to return the room which had the most meetings, and if there are more than one rooms with that number, we have to return the lowest number. So both 0 and 1 have the same number of meetings. 0 is smaller than 1, so our final answer will be room 0. So let's quickly go through the code for the solution. We have defined a method mostBooked, which will return the room which has the maximum number of meetings assigned. As an input, we have got the number of rooms, which is n, and a vector, which is the start and end times of all the meetings. Now we have defined our two helper vectors. One will store the count of meetings that have been assigned to a particular room, so it's a vector of size n, and the second vector is basically, we, as we said, we'll keep a track of the next availability of each room. So this particular vector is going to keep a track of the availability of each room. So again, this is going to be a vector of size n. So as we discussed, we'll be sorting the meetings by their start time, and we'll be picking up the meetings in the order in which they actually occur. So we have sorted the meetings vector. So basically, it's a 2D matrix with x number of rows and 2 columns. Now when you pass a vector of vector to sort function, the sort function by default sorts it by the 0th column, and if there are collisions in the 0th column, then it will sort by the first column. So we actually want to sort the meetings by the start time, and start time is stored in the 0th column, so we don't have to make any changes. We can directly pass this vector to the sort method. And in the problem statement itself, it was given that each start time is unique, so our sort method would never sort by the column 1. All the meetings will just be sorted by the value stored in column 0. Now once we have done this pre-processing, we'll start picking up the meetings one by one, and we'll start assigning the meetings to the rooms. So this is a loop for iterating over the meetings. We get the start time and the end time for each meeting. Next, we have to find the room where this meeting will occur. So we are iterating over each room, and we are trying to find if there's a room that is already available, or we are trying to find the room which will be first available. So if there's a room which is already available, so we'll pick the room because we are iterating it from 0 to n minus 1. So whichever is the first room that we get and which is available is actually going to have the lowest number as well, so we do not need to iterate any further. So if there's a room which is already available, we allocate our meeting to that room, we increase the count for that room because a new meeting has been allocated, and we change the next availability of the room to the end time of the current meeting, and we break from here. In case if we are not able to find any room which is available right now, we try to find the room with the least next availability. So we have kept the least end time variable, which is storing the value of the least availability till now. And if we find a room whose next availability is less than the least end time we have found till now, so we update the least end time with this next availability, and we'll say that we'll pick this room for the current meeting. Now, once we have iterated over all the rooms, we break out. If our allocated value is true, that implies that we have already found a room here. So we do not need to do anything. We have already found a room. We've allocated our meeting. If the value of allocated is not true, that implies that we'll have to wait for a room to be available. And we already have stored the room number which will be available first. So what we do is we pick that room, we increase the count for that room by 1 because this meeting will be assigned to that room, and we update the next availability of that particular room. Now that room will be available at whatever availability is stored here, and this meeting will start from that point and it will run for its duration. So what the next available time will be whenever it's free plus the duration of the current meeting. So that's what we've done. We've added the duration of the current meeting to the next availability time, and that will give us the new availability time. Now once we have done this, we'll finally have the count of meetings assigned to each room. So we have a final loop to check the maximum count for each room, and we pick up the room which has the maximum count. And if there are two rooms which has that max count, we'll return the room number which is lower. And finally, after this particular loop, we'll have the room with the most number of meetings, or the room with the most number of meetings and the lowest number. So we'll just return that answer from our method. Now let's discuss the time complexity. So given m meetings and n rooms, the time complexity is going to be m log m plus mn plus n. So m log m for sorting, nm for these two loops. We are picking each meeting and iterating over each room. So that will take mn time. And then we are iterating through the count vector to find the maximum count. So the count vector is of size n, which is equal to the number of rooms. So this loop is going to take n time. Now we know that the order of magnitude of m is greater than n. So we know that this essentially will be m, and the final complexity will be m log m, big O of m log m. A clever thing to notice here is that since it is a sorting question, the final complexity actually depends on sorting time complexity. If the meetings were small and rooms were large, time complexity would be actually n into m, because m log m then would become a smaller term and mn would become the biggest term, which will actually define the final time complexity. So space complexity is big O of n because yeah because we are using two helper vectors whose size is equal to the number of rooms available. Now with this, we have reached the end of our sorting playlist. We have covered the intuition, concept, problem solving and everything else as promised. Now you need to do your part and go to Leetcode and practice as much as you can. Make sure to practice a good mix of easy, medium and hard questions with a majority of medium and hard problems. And in case if you still have any doubts or feedback, as always, feel free to drop them in the comment section below. I'll see you in the next playlist. Till then, take care and keep learning.